This is a really quick review of expressions and equations. Starting with expressions, they are phrases that include variables and/or numbers, otherwise known as constants, but no equal sign. Here are some examples. You'll notice that the first example has only constants, but the second two have a combination of variables and constants. What do we do with expressions? We simplify them, we evaluate them, and we write them. Next, we'll go over examples of all three actions. To simplify means we rewrite the expression until there are as few terms as possible. There is a process for doing this. We apply the distributive property if we need to, and then we combine like terms. Now, combining like terms means that we take the terms that have the same variable and the same exponent, and we add them together. Okay, so let's look at this example. First, we have to apply the distributive property. So we do that, and we end up with this part of the expression, 3x squared minus 9x plus 6. I've color-coded these so that you can see the like terms. We have two terms with an x squared, the same variable and the same exponent, and so we will add them together, 3x squared minus x squared, and we're going to end up with 2x squared. Now we only have one little term that has just an x with no exponent, and so we add that to 0 and we end up with minus 9x. And then we have two constants, 6 and 4. So we're going to take our two constants, add them together, and that gives us our simplified expression of 2x squared minus 9x plus 10. Now, what do we mean when we say evaluate? In the case of evaluate an expression, I give you the value of the variable and you tell me the value of the expression. So here's an example. Suppose I told you that x is equal to negative 4. And then I ask you to evaluate 2x plus 3 if x is equal to negative 4. Well, it's easy peasy. We just substitute in negative 4 every time we see x, and then we calculate that for our answer. And so the expression 2x plus 3 is negative 5 if x is equal to negative 4. Last, we look at writing an expression. Now, in this case, we're just going to use an example to explain how it's done. We're going to write an expression that represents the perimeter of a rectangle whose length is 3x plus 1 and whose width is x minus 2. Now, I know that you all know that the formula for perimeter is 2 times length plus 2 times width. So, we're going to take advantage of that and just substitute in the length, 2 times the length plus 2 times the width. Now, we have an expression that models the perimeter of this rectangle, but we're not done because we still have parentheses there and we need to give an answer that is as simplified as possible. So we will apply the distributive property here in this step and then combine like terms in this step to come up with our final answer. How about equations? Equations are statements with equal signs. Now the important thing here is in red, with equal signs that indicate two expressions are equal. Here are some examples. 3 equal 3 is obvious, but we also have some more complicated equations there for examples. What do we do with equations? Well, we solve them and we write them. You will be doing a lot of both of these in Algebra 2. Okay, now what do I mean when I say solve? I mean that I'm going to find the value of the variable, usually x, that makes the equation true using properties of equality. There is a process. First, we're going to simplify expressions on both sides if we need to. Sometimes we don't need to. And then we're going to use inverse operations to isolate the variable. Inverse operations are things like, suppose I have a 4 that I want to move to the other side of the equation, a positive 4, then I can subtract 4 from both sides of the equation, because subtraction is the opposite of addition. That's what I mean when I say inverse operations. So let's go on. We have this equation to solve for x. Well, I notice that I do have some simplification to do on the left side of this equation. So I have some parentheses, so I'm going to apply the distributive property. Then I'm going to combine like terms. And now the left side of the equation is simplified. From there, I just need to isolate x. In other words, I need x on one side of the equation and everything else on the other. So I think I'll move that 2 over by adding it to both sides. And then I am going to subtract 4 from both sides, 4x from both sides, and that gives me the solution to my equation. X is equal to x is equal to 2. If I wanted to check my answer, I would substitute 2 in for x in my original equation and see if it checks out. Now, what about writing equations? Well, suppose I gave you this information. The perimeter of my rectangle is 30. And I want you to write an equation that models the rectangle's perimeter if the length is 3x plus 1 and the width is x minus 2. Now, those are the same dimensions that we used for writing an expression. So we know that the perimeter of a rectangle is 2 times length plus 2 times width. So that's the easy part. That's the left side of our equation. But our problem statement told us that it is 30. So anytime it says something is, I can use the equal sign to represent that in a word problem. And that means my expression on the left side is equal to 30. Now I could go ahead and solve this, but I think I'm going to save that for some practice for you to give me as homework. So it's your turn. The first thing I want you to do for number 1 is simplify that expression. In other words, I want you to rewrite it with as few terms as possible. For number 2, I want you to solve for x. Don't forget, this is a Google Classroom assignment for homework. Take a photo of your work, upload your photo to Google Classroom under this assignment, and mark the assignment done. If you haven't already, you need to download the Google Classroom app to your phone to make all of this work. Thanks. Bye.